Yes, first vehicle, how much speed?
55.56.
55.6. Next one.
50.
50. Next one.
54.
55 point. Some.
45.45.
Okay, next one.
52.6.
52.6. Okay, next one. 50. 50. Okay. Now the TMS will be a mean of all these values. How much? Okay, for the time being, we will keep it as the same units as given. We are not doing anything with it. Okay, but later on, there will be some conversions. Okay, now for space mean speed. If I go here, I need distance and I need summation of t upon n, right? Average travel time. Okay, so if I look here, I have the distance. Okay, I need summation of t upon n. Okay, how much is that? How much is this? At last. Yeah. Okay, then SMS is distance upon this value, which is how much?
50.43.
Okay, any problem? Any problem? Picture is clear, huh? Very good. This could be one of the problem. Okay. So you see here, one of them is higher, the other one is lower. This is default. Okay, which one is higher? TMS is higher, right? This is default. TMS is always higher. Okay. Which one I said is over a point?
TMS.
Okay. So it's supposed to be higher because SMS considers the entire section. It is supposed to be higher. Okay. There. Now, here you see for TMS, for SMS, we did the summation of time upon n, right? And then we did distance upon that value, right? How much distance we took? How much is the distance? 1,000. Why did we take 1,000? Because yes, all vehicles have the same distance, right?
Same section.
Okay, yeah, it's the same section. But so for TMS, I can give you any distance because for TMS you will do this, right? For every vehicle you will calculate the speed separately and then you will do the mean. So this one can be 1,000, this one can be 2,000, this one can be 900, 500, anything, right? It doesn't matter because everything is going into the equation. Okay?
What's the point? How can we study the front section together?
Okay.
What's the point of the study if we will take the front distance for TMS?
TMS can be for different distances, this is what I'm saying. Because TMS by default was for a point. We didn't have device. So instead of taking the point, we took the distance and the time. Okay? But still we are taking the individual speed. Still we are taking the individual speeds, right? You are taking each individual speed, calculating speed of, you calculate 6 different values, right? And then you took the mean. So if somebody gave you different distances, you can still do it, right? You can still complete the process, right? Okay. But can you do the same thing with SMS? No. You cannot take times which were taken for different distances and take their mean. It doesn't make sense, right? Got it? All these values of time are for the same distance. Then I can do the mean of time. Got it? But if for vehicle number 1 the distance was 1000 and the time is for 1000 feet, and for vehicle number 2 the distance is 500 and the time is for 500 feet. Now you cannot mix them together. Obviously 500 feet will have much less time, right? If there is a distance of 2000 feet, its time will be much more higher. You cannot do the average of that. Clear? Clear? Okay, so for SMS, distance has to be the same to do the average of travel time. Okay? Some of you will try, let me take the average of travel time, average of distance, average of this, average of grade. Some of you will do that or ask me to do that. Okay? Don't do it. Okay? If the distance is different, you cannot take the average of travel time of different distances. Clear? Okay? TMS can still be calculated because each vehicle has different time, different distance. You are doing the speed differently. Clear? Clear? Okay. So for SMS, distance should be same. Second point was TMS is higher, SMS is lower. This is default because in SMS it is supposed to cover the entire section. So entire section has variation up and down of the speed. Clear? It is supposed to be low. Okay. Now in this case, you see the distance is same, right? Distance is same whether you took it there or took it here. It's the same distance and the same time, same vehicles. Okay. It's still this one is lower and that one is higher. Okay. This is because of the equation. Because of two equations we are using. Okay. You have the prerequisite of this course is what? Two prerequisites, right? Statistics, right? So those people who taught you statistics? Who taught you statistics?
Totlers? For me, Khalid Amin.
Okay. And for others?
Mustafa.
Not Professor Ayatkan, right? Another Muslim. Okay. Okay. So if you ask those people, okay, Dr. Khalid or Dr. Mustafa, you ask them, they would say average is different, mean is different. Okay. We don't consider this. Okay. We say, okay, I'm calculating average, summation upon n. I'm calculating mean. Same thing, right? For us, most of us, average and mean is same. But for them, it is different. Okay? So they say if you are taking mean of the same values, but you rearrange the equation, it will give you a different answer. So the difference here is because of the equation. You look at these two equations. The first one is what? Summation d upon t upon n. Now d and t and n all of same, right? All of them are same. But in the second equation, what did you do? You rearranged it. You just flipped it. Okay? So this flipping, according to them, should give you a different answer. Okay? Whether you are doing in the first method or the second method, it should give you a different answer. Although the values are same. N is same, t is same, d is same. But just flipping the value, doing average first and then summation, or doing summation first and then average, should give you a different answer. Okay? So here it is because of the equations which we are using, but practically SMS should be higher, SMS should be lower, TMS should be higher because of the variation of speed in the section. Clear? Okay. There is a case in which both of them can be exactly same. What is that case? That every vehicle from start to end maintains the same speed. So it started at, the first vehicle is 55.6, right? So from start to end, from 0 feet to 1000 feet, at no point it goes above or below this value. and then all vehicles do the same, then both these values will be exactly same. Clear?
If it goes above what?
Huh?
The speed or the distance?
Whatever speed it started with, it does not go above and down below. It just keeps at the same value from start to end for all vehicles. Then the TMS and SMS can be exactly same. Otherwise, there is no other case. Okay? Clear? And which one I told you I was higher?
TMS.
TMS. Okay. Then we come to another macroscopic parameter, which is density. How do we define density? Give me the definition of density. Mass over volume, right? Okay, mass over volume. So, for traffic, our mass is vehicles and our space is road. So, instead of mass over volume, you would say vehicles upon length of the road. Okay, vehicles upon length of the road. And the length can be in kilometers or miles. So, vehicles per kilometer or vehicles per mile. Okay, why not feet and meter? If you do vehicle upon feet, what's the problem? It's still length, right? It can be. Why not? Now it's thinking.
Huge number, sir.
Very low number. How many vehicles in 1 feet?
How many meter and 1 feet?
How many vehicles in 1 feet?
Point something.
Point something. Okay. It's point something, right? Okay. My daughters bring these toys. Those can be fit like 2, 3 in 1 feet. Okay. But not the real vehicles. Huh? So to have significant figures, we keep the distance in miles or kilometers. Clear? Okay. To have, where did you study significant figures?
Numerical.
Numerical? In the other section, somebody told me chemistry, physics. No? Okay.
We take it in chemistry, no?
Significant figures? Okay. For numerical also? Okay, good. Now, for density, you have to count the vehicles which are in 1 kilometer, right? You have to count the number of vehicles which are in 1 kilometer. Okay? When we say density, for example, of something is 2 kilogram per meter cube. Does it change over time? If I put cement here and its density is whatever, x, will it change? It will not change, right? It's the same density. Cement has the same density. Okay, whether you measure it now or after 5 years, it's the same density. It's constant. We use it in quantity estimation and so on and so forth. Okay? What about traffic? Is it same? No. So I cannot count it now. Because to count, it should remain constant, right?
Yeah.
It doesn't remain constant. So density cannot be counted. Because when you will count it, it will keep on changing. Okay? So density is not something which you can count. Okay? You can use an aerial picture, satellite, drone, airplane. Okay? And the picture, from the picture, you measure the length and count how many vehicles you see. You can do that. Okay? But then you need that thing, right, to take the picture. Okay? I'm sure most of you have your airplanes, so you have to like take them out. I don't have. Okay? So I cannot do it. You guys can do it, right? No? Relax. Okay. But he had, right? He was thinking.
We have bicycles.
Huh?
We have bicycles.
Come on. What about the big car in which you put the bicycle?
Which car?
Your car?
My car?
Yeah.
It's like
You
a
put the
toy.
bicycle in the car, right?
My car is like a toy.
You will not fit in that car. It's like a toy. MashaAllah, you are a big guy. Huh? Okay. But he has a thing. He is thinking. Okay, there is another equipment which we will discuss in the other topic. But the point is, direct counting will not work. Standing on the road and direct counting will not work because the density changes. Okay? You need a picture Use your equipment, okay, to do this. Otherwise, we calculate density indirectly. Okay, this can be done. Okay. Now we discussed daily volume and hourly volume, right? What was the purpose of daily and hourly volume?
Daily volume for design purposes.
Daily volume for design purposes is the correct
Future purposes.
future predictions. Okay, which one is for design?
Hour.
Hourly. Okay, hourly is for design. The speed is very obvious. The speed tells you about the condition of the flow. Huh? The speed is high, flow is good or bad?
Good.
Good. Huh? Flow is good. Speed is low, flow is bad. This can tell you about the condition of the flow. Density is something which is related to all of them and more. Okay? Density is related to traffic demand, which is volume. More vehicles on the road means volume is high. More vehicles are passing, right? Okay, and that also means demand is high. Okay. If density also affects speed. Okay, so density is related to volume and speed, both. Because if you have a section, 1 kilometer, let's say, I have density now 20 per 1 kilometer. After 1 hour, it becomes 30. Okay, so it goes from 20 to 30. Length is same. Okay, so that means the spacing between the vehicles is what now? Less. Okay, when the spacing is less, what happens to speed?
Slow.
Slow, right? It becomes slow. Okay, so density affects speed. Density gives you an idea about demand, volume. Density affects speed. And as I said, more because of the spacing now. Okay, when the spacing is less, now you will be more careful, right? You will have less gaps to change your lane or direction and so on. Okay, so density affects all these things: volume, speed, as well as driver behavior. Okay, all these three things. Now we move on to microscopic parameters. The first, there were 3 microscopic parameters. Okay, we said microscopic parameter is for one vehicle or pair, right? One or pair. Okay, it is speed, headwind, spacing. Okay, we already discussed one of them, which is which one?
The micro.
Micro.
Density.
No, density is macro. Which microscopic parameter we discussed? We did one example, right? In the example, we calculated what?
Speed.
The speed of each vehicle, right?
Yeah.
So these values, 55.6, 50, what is this? The speed of one vehicle. So this is micro. Which one is macro? So until you did this, these values are micro. Clear? Okay. So speed as microscopic already covered. Now we are moving to the second one. So this is the only parameter we will cover for one vehicle. Speed. Only parameter which we cover for one vehicle. That is speed. The remaining 2 which we will discuss now are for a pair of vehicle. Head. So first one is spacing and then the next one. Okay. Both of them are for a pair of vehicle. Now what do we mean by a pair? Pair means they are in the same lane following each other. Okay. Pair means 2 vehicles in the same lane following each other. Okay. So 2 vehicles are going together. For traffic analysis, not a pair. Okay. Clear? One vehicle is going, then we have a truck, and then after the truck there is another car. So the pair can be vehicle and truck, or truck or the car. It cannot be this car and that car, because they are not following each other. Clear? Okay. So pair means they have to be in the same lane and they have to be one after another. Clear? Consecutive. Okay. Now, if you have a pair of vehicles and you measure the distance between them at any point of time, this is called as spacing. Okay, spacing is a distance between a pair of vehicles. Clear? Now, in this distance, the length of the vehicle is included. So we have to measure it from the same point. Okay, what do I mean? So you start measuring the distance from the bumper. Okay, how long you will measure or where you will end it? At the bumper. You started from the front bumper of the first vehicle. Where you will end it? Front bumper of the next vehicle. So you see the length is included, right? You start from the bumper, length, and then the space, right? So length is included. Okay, clear or not? Can you see this? So I started from here, length included, and I will end here. Okay, now if I start from here, rear bumper, then space, and again I will end it at the rear bumper. So length is included. Got it?
Why isn't it just the distance between the two cars?
Huh?
Why isn't it just the distance between the
Just
two
for fun. Because length has the effect. Length has an effect. Okay. So if you do it without the length, then you have to tell me, okay, this was a truck and the spacing was this much. This was a bike. Okay. The spacing was this much. Okay. Now you don't have to tell me. It's already ordered. So trucks will automatically have more spacing because they have more length. Got it? Between two cars I will have less spacing because they have less length. Now I don't have to worry about what type of vehicle was this. If you just take this was the instructor's value. Right? The instructors, when they say, oh, keep distance, when you are learning how to drive, they are focusing on that distance. Okay, the clear distance. Okay, but in traffic, you want the distance to include the length. So whatever is the effect of the length is already included. Otherwise, you have to tell me with every distance what vehicle was it. So give me 100 values, and with each value, okay, this one is for truck, this one is for car, this one is for. Okay, so we save ourselves this headache, and we say, okay, put it there. When I will do the average, if there are more trucks, it will automatically be high. If there are more cars, it will automatically be low. Done. Okay, people. Not me. Okay. What are the units of spacing? Besides spacing is what between two cars or two vehicles? Distance, right? Distance. Okay. So after this distance, I have a pair of vehicles, right? Okay. So after the distance, I have the next vehicle, right? After this distance, I have the next vehicle. Okay. So this is distance per vehicle. Distance per vehicle. Okay. And if I do the inverse, it becomes vehicle per distance. And vehicle per distance is what? Clear? Okay. So I do the inverse of average spacing. Average spacing, it gives me density. Okay. Spacing is distance per vehicle. I do the inverse, it becomes vehicle per distance, which is density. And what is this? Constant. Yes, it's a constant, obviously. But why is it here?
Number of vehicles.
No. This is the conversion factor. This is the conversion factor. Okay. Now, the density is in vehicles per mile. Vehicles per mile. I told you, if you take it in feet, it will be a very small number. But it's the reverse with the spacing. If you take the spacing in miles, do you have a spacing of 1 mile between two vehicles? No. It's in feet, right? So you have to take the spacing in feet, and you have to take the density in miles. Otherwise, you will have very small numbers. Then you need the conversion factor from feet to miles. Clear? Okay. Now, two things. One is shown here. One is one I said. I told you DA is what? But it should be average spacing. Okay, average spacing. So that means you have to take multiple values and do the average and then calculate density. You cannot put one value of spacing here. You have to put the average. Now if for average you need different multiple values. Okay, why?
To be more accurate.
To be more accurate, yes, you take more values, you become more accurate. Yes, this is correct. Any other reason?
Because it's the average also.
Which one is the average?
The spacing. Average.
DA is spacing, average is spacing, but why I'm saying why do we take an average?
Because the values are changing.
Huh?
Because the values are changing.
Which value is changing?
Spacing. Between the equals.
Let them change, but I said if you look at the equation, inverse of spacing is density. Vehicles per unit length and length per unit vehicle. The conversion is very simple. Why should I take an average? Why should I take an average? Just put one value, it will still give you an answer. Right or wrong? It will still give you an answer. Okay? So why should I take an average? Anybody? No.
Accuracy.
Okay. Yes, accuracy, but one more thing which is more technical. Okay, we have two types of parameters, right? We have two types of traffic data. What?
Speed and spacing.
No. Two types of traffic data.
TMS and SLS.
No.
Macro, micro.
Yes. Okay, macro and micro, right? Density is what? Macro, right? And spacing is micro. So spacing can be between a pair, but density cannot be. It has to be for the whole flow. Now you tell me, if I just take the spacing between one pair of vehicle, and I say, okay, now calculate density for the entire flow. Is it correct? It cannot be, right? Okay. So to use a microscopic and then calculate macroscopic, which is density, then you have to take an average. Okay, otherwise it doesn't make any sense. Okay, you took one value and saying the whole class is measures. It doesn't make any sense. Okay, so that's why. Another thing which is mentioned here, this is vehicles per mile, and LN stands for lane. Vehicle per mile per lane. Okay, we did not discuss per lane earlier. Density can be without per lane, no problem. Density can be without per lane, but in this equation it has to be per lane. Why? I told you the reason. Why it has to be per lane? For this equation specifically. If you calculate from this equation, it has to be per lane. Why? How do we define spacing?
Two cars follow
Which two cars?
follow each other
In the same lane.
In the same lane. The spacing is default in the same lane. So density, if spacing is for one lane, then density is also one lane. Got it? Got it? Okay. Density can be for 3-4 lanes, no problem. But in this equation, we are using a spacing, which is per lane. Okay. Clear? Okay. That's why. Okay. Now we move to second or the third microscopic parameter, which is head weight. Okay. If you measure time interval between two pair of time interval between a pair of vehicles, it is head weight. Okay, and pair means the same thing, following each other in the same lane. Okay, so two vehicles are following each other, they are in the same lane. You measure the head weight between them. It is, you measure the time between them. It is head weight. Clear? Okay. And you have to do it again for the same point. Okay. So I have for the head weight I will use a stopwatch, right? To measure the time I will use a stopwatch. Okay. So you are measuring at this point. Okay. So you were looking at your Instagram and a car passed. So you started the stopwatch. Right? When did you start? With the front bumper. When will you stop? When this bumper reaches here. Clear? Okay? Let's say you were late. You were looking at a very interesting post. Okay? So you were late. So you started with the rear bumper. Okay? So now you have to end when this rear bumper reaches here. Clear? Okay? So same reference. Now what are the units of headway? Seconds, right? Seconds, okay? And you are measuring between one vehicle to the other, right? So it's seconds per vehicle. Seconds per vehicle. And if you do the inverse, it will become vehicle per time, right? It is time per vehicle. If you do the inverse, it will become vehicle per time, okay? So inverse of average headway is flow. Inverse of average headway is flow. Flow was unit vehicle per time, right? Flow was vehicle per time. Okay. So inverse of average headway is flow. Okay. Now what is this? Conversion factor. Okay. It converts what to what? Second to hour, right? Now if you put this, then it becomes rate of flow. Because of the conversion factor, now we will not call it flow because if you convert it to what? Hour, right? Flow is not for hour. Remember? Flow is not for hour. So when you convert it to hour, it became clear? Clear? Now, without this, flow. With this, rate of flow. Without this, what was this? Density. Without this, density. It doesn't change. But the value will be very small. Get it? So this conversion factor is just for significant figures. But this one will change the definition. Because without this it will be per second. You cannot call it rate of flow. You will call it flow. With this, it's rate of flow. Okay, and again you will use the average value, and again this is per lane. I already explained why is that. Okay, average because it's you are converting to macro, which is for the whole flow, and per lane because headway is between two vehicles in the same. Clear? Okay. Okay. Now in this course you will see we will be using macroscopic parameters. Macroscopic parameters. Okay. Microscopic parameters are very rarely used, especially in traffic engineering, which they are very rarely used. Okay, but so we will not be talking about them throughout the course. Okay, so I will tell you what is the need of having microscopic parameters. There are two main reasons of getting microscopic parameters. I am talking about headway, spacing, and the speed of individual vehicles. Why do we need them? Two main reasons. Okay. One reason is to do these calculations. Okay, you can calculate density from spacing, you can calculate flow rate from headway. Okay, so I need flow rate, but I cannot count it. I can find out headway and do the calculation. I want density and I cannot count it. I already told you. I can do the spacing and calculate density. Clear? So one reason of microscopic parameter is to find out the real thing which I want. Okay, one reason. Second reason is to study individual behaviors. Okay, I want to study, for example, now we have, let's say, they start to import these automated cars, driverless cars, and now we have so many of them in traffic. Now I want to see how they are behaving. What is the difference between these cars and the normal one when they are moving in traffic? Okay, so I will not deal with macroscopic parameters. In macroscopic parameter, everything is included. When you say volume, volume means everything, right? Density, vehicles, all vehicles, right? Okay, so in this case, to study these automated cars, I will use their microscopic parameters, their headway, their spacing, their speed. Okay. Similarly for drivers, I want to study young drivers, very old drivers. Okay. So again, I cannot combine all of them. If I take macroscopic, the bigger one, everything will be combined. So I have to take microscopic. Clear? Okay. So microscopic for two reasons. One for calculation of macro, the other one for studying individual behavior. Okay. Now spacing was distance. Spacing means distance. And headway is time, right? Spacing is distance, headway is time. Distance upon time? Speed. Got it? So the final equation. dA is spacing, HA is time, distance upon time gives you speed. Again we are taking average. If you don't take the average, it will become speed of 1 v. You take the average, it becomes the average speed. Clear? And what is 1.47? Conversion. Whatever you don't know, it's conversion. Okay. So this one is for miles per hour, and this one gives you in kilometers per hour. Okay. Okay. Let's say we have a congested multi-lane highway. Spacing average is given, highway average is given, and we have to find out the rate of flow, density, and speed. Okay, density was inverse of spacing with this factor. So spacing is this. What is my density here?
26.4.
26.4 vehicles per mile per. Okay, flow rate. It was inverse of headway, right? So the factor and 3.8. How much?
947.3.
Okay, any problem? There? Okay, and the speed was what? So spacing is 200, headway is 3.8. I need the conversion factor. Yeah. How do I write it? Yes.
Three 5.8.
35.38.
8.
Okay? Clear? What about this one? We have the headway and we have the speed. They're asking for flow rate, and density. We have the headway and we have the speed. They're asking for flow rate and density. I'll go here. You have the three equations in front of you. Okay, the headway is 2.4. Okay, and the speed is 55 miles per hour. Now tell me the flow rate and density. I'll put it here. Okay, so you have to use the same equations. The headway 2.4 and the speed 55 miles per hour. So what will be density and what will be flow rate?
Didn't check it
40, short. You calculate density directly.
I forget that.
The flow rate is 1,500 liters per hour.
Okay, and the density is? Very difficult, right? Very difficult question.
Don't complicate.
We have multiply them and plug it in the equation.
Very good.
For the density, we have this speed given, right?
Yes.
And we have this, we'll find out what's the spacing.
When will you do it?
We'll do that using elastic.
When will you do it?
27.2.
Huh?
27.
Yes, 27.2. Yeah, see, he could be wrong. Huh? Nobody would know. As far as this class is concerned. Right? Nobody would know. Huh? Okay, how did you get the flow rate? Tell me. What do you do?
Flow rate?
Yeah.
3,600 divided by the weight.
Divide by the head weight. Simple? Okay. Clear till now? No problem. How do you get the density?
Multiply the head
Yeah,
weight.
genius. Here, head. Okay, genius, expert.
Multiply the head weight with the speed.
Multiply the head weight with the speed. So basically this thing, right?
And multiply it by 1.47.
Yes. So this.
This.
Okay. You put the speed here, you then put the head weight here, and you will get spacing. Okay, and then
We get the spacing, then D.
okay. Here. Huh? Multiply the equation.
Yeah, then put it in the D.
Very good. I was telling my other class that now we need everything automated, right? Why should we do it? Okay, a time will come. What's your name? Yeah, Jabbar will be doing this with his hand, and you saying, okay, do this, and the calculator will do it. A time will come. Okay, inshallah. Right? Clear? Is it clear? Any question?